Hi everyone, welcome to my channel. My name is Fikret. In this end-to-end course, we're gonna dive into amazing world of real-time analytics in Databricks. I'm excited to take you there. So what is Spark Structured Streaming? Spark Structured Streaming is a scalable, incremental, and fault-tolerant stream processing engine that's built on Spark SQL engine. So its primary purpose is to handle continuous, unbounded streaming data. How does it work? Let me explain on the example of diagram from Spark official documentation. So at the top you can see the input source, which gets constantly change. So let's say at one point in time we have small data set, and as time goes by more data is being added to the source. So Spark Structured Streaming reads all this data on certain frequency, applies transformations, keeps certain part of this in memory, and then writes into the destination. So we'll talk about available source and the destinations, and we'll also have a detailed discussion around how Spark Streaming handles its internal state. But for now, this simple explanation hopefully does the job. So in Databricks, you can use Python and Scala to build your streaming pipelines. Some of the use cases. So as I mentioned, Spark Streaming is primarily built to handle low latency real-time streaming pipelines. Depending on your data speed and the size, you can get up to 1 millisecond latency. What's interesting is that Spark Structured Streaming can be a great tool not only for real-time analytics solutions, but you can also build your batch pipelines or ETL pipelines using incremental sources. Of course, there are some limitations, but using Spark Structured Streaming would allow you to handle some of the data engineering challenges like building watermarks or building incremental ingestion logic relatively easily because of built-in mechanisms for handling incremental data. I already mentioned some of the advantages. So you can use similar batch and streaming APIs, which makes learning structured streaming very easy task. Let's talk about some of the key concepts. So standard pipelines built by Spark Structured Streaming guarantees your data delivered exactly once. So that protects you from some device-related duplicate events. But as we will see, there are some use cases where you have to go a little beyond the standard streaming transformations by using some custom sync types. In that case, you have to build your own logic for delivery. And in that case, you can end up with at least once delivery guarantee. Checkpoint-based fault tolerance is another important part of streaming. When building streaming pipelines, you have to specify locations where log files will be written. And Spark Structured Streaming uses these log files to handle certain failures. For example, if your stream has been canceled manually or has been terminated because of some compute issues, you can easily resume your stream without worrying about integrity of your data. Now, let's talk about timestamps. So when building your streaming pipelines, you have to differentiate between different types of timestamps. There are event times, which represents time when events have been generated on certain devices. And the processing time represents the time when it arrives to your system and is processed by Spark. So as we'll see shortly, it's best to use event time on many types of transformations, especially when you are using joins or aggregations. But even if you don't have event time as part of your data, you can still use processing time. And the state management is another important part. As I mentioned earlier, Spark keeps internal reflection of your data as it processes and applies certain transformations. And depending on your transformation types, you have to know differences between stateful and stateless transformations. So let's talk about available sources and destinations for Spark Streaming. Spark Structured Streaming can ingest the data from Kafka or event hubs. You can also ingest from storage files. So we'll be building our demo around storage files in today's tutorial. And there are many types of files that you can ingest from. You can also read the streaming from delta tables. However, keep in mind that these tables needs to be append only. So if your delta tables requires some updates or deletes, you won't be able to build outgoing streaming pipelines from these tables. And then there are some other sources which are more useful from testing perspective. So I have listed some of them here, like RAID, sockets. In terms of sinks or destinations, you can write your streaming into Kafka or Event Hub. You can also write into storage files, delta tables. There are some custom sinks, like for each batch and for each. So these constructs allow you to overcome some of the Spark Streaming's limitations. For example, you cannot write into database directly by using standard streaming methods. However, these two methods allow you to overcome these challenges. And then you can also use some test sinks like console memory to test some of the quick solutions in your development environment. Some of the streaming challenges, I already mentioned some of them. So many destinations that are available from batch data frame perspective are not available for streaming. You need to be aware of state management for large data sets and choose correct output modes, because it can affect memory resources required for streaming processing.